and welcome to CloudFest. Good to see that so many people have turned up after all this hard partying last night.
Oh yeah, that was it. Simon, tell us, give us a short overview on who you are, where you're coming from, what's your background?
Yep, my name is Simon Pearce. I am a system engineer and I work for a company called SysEleven. We've been running managed applications for our customers for the past 11 years from Berlin.
Okay, so you're residing in Berlin?
Yes.
But you're not born in Berlin?
No, I'm actually from England, from Bristol.
So that's what I figured. So tell us about the presentation you're holding. What's the overview on it? Give us a brief abstract of it, please.
Okay. Well, basically, I want to talk about managing and running multiple clusters in hybrid setups. So we're talking about Kubernetes, about what our approach is to running Kubernetes as a managed environment for our clients, and also about the way you can basically run hybrid clouds, integrate your own data center, and also maybe other cloud vendors.
So I heard that funny word for the first time this morning, so I will listen to you closely.
Okay.
So I know it better afterwards. Have fun, it's all yours. Thank you.
Thank you.
Thanks.
Okay, so to give you like a brief abstract about what we'll be talking about, we're talking about managing and running multiple Kubernetes clusters in hybrid setups. It's quite a long task. So I'll give you a short agenda about what I'll be talking about. We're going to start off with, like, to make sure we're all on the same page, why do we actually run containers? What is so important, what is so vital about running container infrastructures? When I talk about containers, I'll often be referring to Docker, but I prefer not to use the phrase Docker, so I thought, okay, I'll just use containers because it's basically a general thing. And there are also other container runtimes available which can be used. Then we'll talk about why Kubernetes. Why do we want to run containers and then build all this abstraction layer on top of it again and make it even more complicated? Why do we even do all this and make all this effort into getting all these different components and moving parts up and running to achieve something which we could probably just get a system to unit file, start the container, and it would run, or do it on my laptop? Why do we actually do this? Then I would like to show you a short demo of our managed Kubernetes offering. It's called MetaKube, and I would like to compare why it's good to use a managed Kubernetes offering, what are the advantages, pros and cons of doing this, and go through some of the options that are available. Okay, so let's get going. I've got 20 minutes, so let's rock. Why containers? One major thing about containers are containers can be run anywhere. So you can basically run a container on your laptop, on a virtual machine that you may booted. You can start them in the cloud. You can even put them on your NAS at home if you want to do various things. It makes them very portable and gives us a system which you can basically move from A to B without any major changes. Configuring a VM could be like Kubectl. You can move it, shift it somewhere else, just to another OS, to another operating system, and it works completely differently. Some of these things we can eliminate with running containers. A service-based architecture. So you could also use the phrase microservices. I choose not to use microservices here. It's one of the kind of buzzwords which is very hyped at the moment. But what we're basically looking at is services, connecting different services together to make an application, instead of having everything as one monolith on one machine. One of the most important things is having an isolated environment, having all those dependencies, everything that I need built into that one container. Thinking about complicated applications, if one application on my large monolith server needed a different version of a programming language, of Python or something else, I will not able to update application number 1 without touching and maybe even breaking application 2 running on the same server. This is completely eliminated with containers because I have everything I need in that one artifact. So every single microservice from my architecture can be updated individually. And I can look, restart, configure, and scale each of these environments individually. Application sandboxing. Application sandboxing allows me to do lots of things. It basically allows me to build silos from my applications. And also limit and configure the resources which are required and needed for each individual application, which of course should hopefully reduce a lot of overhead, which you would normally have when you run everything in single VMs. It can also be a lot easier to develop. Why? Because you can pull images from Docker Hub, for instance, to go back to the Docker terminology. You can run them on your laptop. You can push them to a registry, and you can be fairly confident that the stuff that you have built is going to also work in the same manner in production, which is really nice. Instead of having all these vagrant boxes that you may be trying to run on your local machine, clogging up all this RAM, trying to get all this running. I know how important it is for developers to run these things on their local machines, and that makes it definitely a lot more easier. It's also a lot more easier to integrate things like CI tooling and other things into this procedure. Easier to deploy. You've got your continuous deployment tools. Just to name a few of them: GitLab, Jenkins, Scaffold, Knative from Google. There's loads of them around, and they make it extremely simple to actually shift your applications into and to deploy your applications into Kubernetes. And hopefully, at the end of the day, we can save a lot of bucks out there as well. Because if we're saving resources, we can also improve the amount of resources that we require, and also maybe the monthly cloud bill, which we get at the end of the month, which could be very high if we don't do these sort of things and don't look and address these sort of problems. So at the end of the day, what are we doing? We've got a happy boss, I hope, because we're like saving money. So that's good. We don't want to be spending everything like on cloud resources. So now we've spoken about like why are we running containers, why are we maybe running Docker and other things, why does this kind of make sense? So now we've done all these things, and now at the end of the day we sit down and then we build Kubernetes on top of all of this. So we've got loads of moving parts, loads of different things. Why do we want to do this? It seems a bit crazy. And it did when I saw it first as well. You think, okay, I'm running on top of a cloud, probably virtualized networking, virtualized storage. On top of that, I'm maybe got VMs, a hypervisor, and then on top of that, I'm running containers until I actually get to my application. It sounds crazy, but it does make sense, and it's still very powerful. So Kubernetes is a production-grade container orchestration, built by Google, highly based on a system called Bork, which Google used today to orchestrate services like Gmail. They run a multiple number of millions of containers every single day. They terminate them, they scale them, they have a round-the-world system. Because when people are awake and using Gmail and consuming services in Europe, most of the people in America are probably asleep. So they won't require any resources there. And that's where they save a vast amount of money doing those sort of things. And a lot of these ideas and concepts have gone into Kubernetes, and we are able to take these concepts now and to use them for our businesses. A few years ago, this would have been impossible. We have a standardized API and API objects we can speak to. So we can basically not just run our infrastructure as a code, which we did a few years ago, and also a lot of people do now. Think about CloudFormation, Terraform, and tooling like this. We can also standardize our complete application, build pipeline, and also the way we speak to the API. So we can throw JSON, YAML against this API. We can see the result instantly, and it's also reproducible over systems. We can keep all of this code in a repository, version it, and use it again and again. And we can even deploy it on different clouds, setups, or, as I said, on your own machine. It all works. There's systems around like MiniKube, a mini version of Kubernetes, which you can run as a single deployment on your machine, just to test how your own application would look like and how Kubernetes feels, without having to build up a vast amount of infrastructure to actually do that. So a standardized API and objects make working with Kubernetes very easy. Yeah, deploy anywhere, including hybrid deployments. So it runs on your own data center, it runs on OpenStack, on Google, on AWS, anywhere where you want to run Kubernetes, you can basically run it. You have something like automatic scaling of services. So you've got something called a horizontal pod autoscaler, which allows you to horizontally scale the number of pods you have. You can scale them down and up. There's also node autoscalers available to increase the size of your cluster if the pods don't fit on that cluster anymore because you've completely outgrown what you're running on at the moment. And there's a lot of effort also being putting into vertical pod autoscaling. Vertical pod autoscaling means basically patching resources and changing resource limits of running containers. So allowing that container to consume more RAM or more CPU than it did before. Because sometimes it's not just enough to increase the actual replica count of your pods. That can allow you, of course, to increase your throughput and the amount of traffic that you're going to be able to have. But some of the other things, if your Java app is just crashing because it needs more RAM, this is not going to help just increasing the replica count. Service health monitoring, also something that basically comes out of the box with Kubernetes. All you need to do is add 3 or 4 lines of YAML to your code, and you can automatically check a predefined endpoint within your application. You might have something like /status built into your application, which would then allow you to monitor the health status of your application. You can do this to find out when is my application ready to accept traffic. This is called a readiness check. And you can also use health checks while your application is running. When Kubernetes sees the fail count go up, you can configure this threshold. It will basically kill this pod and spawn a new one because it will see this pod is basically broken, which of course can save us a lot of time. I'm not sure how many of you have done like on-call duty during the night and you've got up because some system is just doing weird things. Kubernetes can basically help us and solve quite a few of these problems. Of course, not all of these problems, but a lot of these problems. Automated rollouts and rollbacks. Things like the deployment API object have these sort of things. You can basically run version 1.0 of your application in the deployment. Your developer pushes a new version of the container 1.1 to the repository, and you can get this either automatically through a CI tool or manually with kubectl, if that is the approach that you would like to take, and get this rolled out. You can teach Kubernetes with a few lines of YAML again, how many pods may fail during that upgrade. So then you can basically roll back to the state that you had before. I hope this doesn't happen very often in production, because otherwise you could be left with something with a short panic mode. But Kubernetes is going to stop that deployment once it notices that 1 or 2, depending on your configuration, of these new containers have failed, because maybe something you didn't notice, that there was a memory leak or something else within your application. Yeah, public and private cloud support. All of the code that you basically need to run Kubernetes on OpenStack, on AWS, on GKE, to consume storage, IP addresses, to create new machines. All of this is already being coded for you. You don't need to take care of this. It's already in the cloud controller. You can load the cloud that you need at the time, depending on where you've deployed, and just get this up and running. Include your storage class, and then you're good to go. Okay, next I would like to show you a quick demo of MetaKube. I was hoping to show a live demo here, but as you can see, this facility doesn't really have the possibility to put my laptop anywhere. We've got a big stage, so I decided to do a short screen recording, and I would like to show you this now. For people looking closely, you will probably see I've actually done this on one of our dev clusters. I did this purposely because I wanted to show you a few features which we are going to be releasing within the next weeks. Otherwise, our URL for MetaKube would be metakube.syseleven. Okay, so I'll start off the video then and give you some explanation what we're going through. I'm basically logging on to our OpenStack Cloud through Keystone. I'm using this as an authentication to log on to MetaKube, and from there on, I am going to create a cluster called CloudFest. I can basically, give a name for my cluster. I can choose the Kubernetes version that I would like to run. If that's needed, normally you can use the latest version. You can choose the cloud environment you want to run on. We have like AWS and also OpenStack. We have 2 different regions in Berlin which you can choose from with 2 individual storage zones. After that, all you need to do is enter your password for OpenStack. You can then choose the project that you would like to run on, depending on how many projects you might maintain for clients of yours, or how many different applications you may want to run. You then have the possibility to actually choose the flavor for your worker nodes, so how much RAM, CPU would you like to allocate to these worker nodes, and also the count. We also offer 3 different Linux operating systems that you can equip your worker nodes with. It's CoreOS, CentOS, or Ubuntu that you may use. So once we've done this, I quickly opened up the Advanced tab, so you can also, for advanced users, you could also you add your own security groups or your own networks if you wanted to. You may want to do that if you wanted to integrate other VMs into that network. From there onwards, it's just like a click on Create. What it's doing, it's basically adding my SSH key to the worker nodes, and then I sped up the process slightly here to not let us wait for ages, or for 5-6 minutes, until all these VMs are booted up. It will seem kind of silly to be standing here and waiting for that to happen. So what we'll see next, we will create a node deployment. A node deployment is similar to a Kubernetes deployment. Basically, it is one. It allows you to then do rolling upgrades and things to the next version. So you don't basically have to do much to upgrade your Kubernetes cluster. It's one click in our interface, and then it will start upgrading the master components, and will then go through the rolling upgrade procedure of upgrading all your worker nodes. So you can see at the moment we're running the most current version. Our 3 worker nodes have been created. They've all been allocated an internal and an external IP address. We have a short node event underneath to see what's happened. And basically, after that, we're basically good to go, and our cluster is up and running. We then deploy a few add-ons for you. So we deploy a few backup add-ons and Helm, so you can start using Tiller straight away, and you don't have to do that. Once this is finished, it will take a maximum of about 8 to 10 minutes. You can basically download your kubeconfig and start deploying your first application. In an ideal world, you would probably want to start getting that kubeconfig into your CI tool and clicking on deploy my application from there. So that was basically a short demonstration how simple it is to set up a cluster in MetaKube. Okay, then a bit about the pros about running a managed Kubernetes setup. Quick overview of the CNCF Cloud Native landscape. One thing I'm really proud of is that you can see in the bottom between all these giants is our company, SysEleven. We're also a part of the CNCF landscape with MetaKube, with our managed Kubernetes offering, and we're also complete Kubernetes compliant as well. So every time we change things on our cluster, we run these tests, which are given from the Cloud Native Foundation, and as long as they all pass, you're good to go. So, managed open source Kubernetes. We basically, except the web interface, everything we are running on is complete open source Kubernetes. And also the machine controller is a few specific things in there, but most of that is also going to be open source. Everything is running on SysEleven managed infrastructure. So all of the OpenStack, all of the storage is all managed by SysEleven. It also offers, as you can see, MultiCloud support. So we've got a wide range of clouds which you can use. So it would be fairly simple for us to also integrate other cloud vendors, for instance, DigitalOcean or GKE. We've basically focused at the moment on OpenStack and AWS because we think that we can reach most of our clients with these 2 offerings. And this is basically a very simple abstract of what a hybrid cloud could look like. So on the far left, we have your application, which you're basically posting towards MetaKube or towards the Kubernetes API. And behind that, we could find the SysEleven stack, our 2 OpenStack clouds. We could have AWS, or we could also see your own data center, which we could also integrate into the product, which would also allow you to consume and use resources which you already have and you've already acquired. Carefree usage. What do we mean with carefree usage? Carefree usage basically means SREs in our company have sat down and thought, okay, what is best? What do you actually need? Lifecycle management. Lifecycle management is a pain in Kubernetes. Updating these machines, getting them all in running, so people decide not to do it. Bad idea. Modern products like Kubernetes have also seen quite a lot of security issues and other problems. At SysEleven, we can address these issues for you straight away. We have pre-installed add-ons, monitoring, backup, and things like HashiCorp's Vault, where you can store secrets, can easily be added over the interface to give you an environment which is secure and good to run your application. Everything is managed by the SysEleven SRE team, and you can also call us. We have customer support. You can call us. We can help you. We can look at your cluster. We can give you some assistance if needed. And the best thing, it's all made in Berlin. Okay, so that's me done with my slides. I think my 20 minutes are just over. And does anyone have any questions? Anything that you would like to ask? A few of my colleagues are sitting here as well in the audience. And one of my colleagues came up with a really good idea. He said, okay, everyone that asks a question gets a hoodie. So,
very important. Okay, hold on. If you have a question, please wait for the microphone because we're recording for the web, so please wait for the microphone. Here you go.
Where is your cube at the show? What is the number so I can go and get some information?
Sorry, can you repeat that, please?
I ask where can I get more information? Where is the cube at the show? What is the number?
We have a booth here, so you can come around anytime you would like to. You can talk to us. We're here. You can find all the information that we have on syseleven.de/MetaKube. And yeah, come around, join us in our booth, and you can ask us.
All right, there's the first hoodie.
Thanks.
To be supplied. So once again, if you have a question, please raise your hand, wait for the microphone, and pose the question now. There's one in front here. And if you don't have any question, raise your hand anyway. You got a
you get a hoodie. Yeah,
hey.
Great idea.
How many do you have, Simon?
We have a few boxes
We got
of them.
plenty.
Okay. We're not planning on taking them home, so.
Hi, so seems interesting. Do you provide evaluation versions or testing grounds?
Yes, we do. Yeah, we do. Please drop by our booth later on. Speak to my colleague Florian later on, and there's people who'll be offering you an envelope on the way out. Just grab one, and you can find out how you can test. Thank you.
Hello.
Hi.
Hi. How can we do this rolling updates and rollback?
Okay. Well, basically, rolling updates is a part of the API object deployments. So basically, you can add a deployment strategy. Often, the default strategy should be a rolling update in the deployment API object. You basically want to add something called max surge, so how many pods can actually be overcommitted. Of course, you need those resources as well, because ideally you want to add a new pod with the new version before you take an old one away. And very important, the max unavailable option. You need to add that to make sure that you don't take all your pods offline without having a reliable new one in place.
Can it be done through the MetaKube interface? I mean, MetaKube.
This is basically part of the Kubernetes API. So you don't actually do the deployment. We deploy the cluster and the infrastructure with MetaKube. Afterwards, you would basically either use a CI tool or use kubectl as the command line client for Kubernetes.
Thank you.
Thank you.
Any further questions? Anybody in favor of a hoodie? No. Yes. Come on.
Okay.
Oh, back there. Anna, you're saying thank you.
Hi. If you're using MetaKube to connect to your own data center, a Kubernetes cluster in your own data center, is there any minimum requirements needed, a minimum version of Kubernetes, or does it work with every data center, every version of Kubernetes, etc.?
Good question. So in an ideal world, you would want to be running something if you're running an on-premise solution like OpenStack, so that we have an API which we can connect to actually boot virtual machines for your worker nodes and have certain things like storage layers via the Cinder API, IP address management. If you just had a bunch of machines, then we could also deploy stuff on it, but it would be very limited in its usage. Thank you.
Sir, did you have a question because you raised your hand? Yeah? No. Any further questions? Everything has been answered.
Good,
So-
excellent. So if you...
Stop. Back there. Sorry, sir. We didn't see you. You were out of the lights.
Hi, how about the GPU acceleration? Is it available within the containerized environment or?
Good question. It's actually something that we're looking into at the moment. At the moment, we're focused on making 85% of the customers happy. And most people don't require this at the moment or request GPUs, but it's actually something we're looking into and something that would definitely be possible over the integration with AWS.
Thank you.
Thank you. So if any other questions pop up later on today or tomorrow, then please don't hesitate. Drop by our booth. It's at HO1. You can see it. We're on the with Rausch right when you come in through the main entrance. And thank you very much for listening.
Thank you, Simon.
Thank
That
you.
was Simon Pearce.